Yeah, welcome everybody. So nice to see so many people interested in hearing a little bit about the history of our beloved toolkit, Qt. And as you have been told many times already this year, we are celebrating the 30 years anniversary, actually this month precisely, of Qt. My name is AAVITSLAND, and I have been working with Qt, for Qt, mainly in development for almost all of those 30 years. So the theme for this talk then will be more precisely the history of the graphics in Qt. And in this context, that means the classic two-dimensional user interface graphics, like we see an example of running here in a Tetris game made with Qt 1, actually. There are, of course, a lot of other talks here, as you know, about the wonderful things we are doing in 3D and virtual reality and so on. But here we will be focusing on classic 2D user interface graphics. So I'm thinking about following the 30 years timeline in a kind of history of art or history of architecture of Qt GUI graphics, starting out with the antiquity of Qt 1, going through the Middle Ages of Qt 2 and 3, before entering the renaissance of Qt 4, the modern times of Qt 5, before reaching our contemporary time of Qt 6. And rounding off with a little glimpse into the future. So, without further ado then, our story starts out in the early 1990s. And the field of user interfaces looks more or less like this, that on the commercial Unix workstations, the vendors have standardized on the X11 Windows system and the CDE desktop environment, while on the IBM-compatible PCs, Microsoft is winning the competition for the graphical user interfaces with their Windows product, and at this time we're talking version 3 and NT. Apple is not yet a major commercial player, but their Mac OS, at this time at Mac OS System 7, is still an important player in the GUI world because it's so creative, it brings new concepts to the market. So for software developers then, the world looks like this then, that the different Windows systems have different APIs. Different widget sets, meaning the collection of buttons and menus and so on, like Microsoft Foundation classes on Windows, or the XT or Motif widget sets on Unix X11. And each of these are built on top of different painting APIs, different graphics engines, like the graphics device interface on Windows and the XLib graphics on X11. So the challenge then, what do you do if you want an application to run on more than one of these? Do you have to write it twice or three times? And the quick and dirty, so to speak, solution to that challenge would be to put a thin cross-platform wrapper API on top of the native widget sets. So like a thin wrapper providing, say, a common button that is backed by an MFC button on Windows and a Motif button on X11. And a couple of products like this actually existed at the time, and they would work great for your hello world and your very basic interfaces. However, it quickly broke down when you tried to make something more advanced for the basic reason that the API of this wrapper would be limited to the least common denominator of the functionality of the underlying widget sets. So then the history is known that a couple of young Norwegians, Håvard Nord and EIRIK Eng, indicated here in the photo, had the crazy idea about a whole different way of doing a cross-platform application framework. Namely, let's just drop the native widget sets altogether and make our own from scratch, a common widget set, a cross-platform from scratch. And implementing that would then need a painting API, because using the native ones directly, then you would need to write your widget set twice again. So they got the idea, well, let's instead put a thin wrapper on top of the native painting engine. So effectively then moving the cross-platform wrapper one level down in the stack. And these Norwegians started developing this idea as a product and founded a company to do that, hiring a few friends to help out. In the photo, we're on an early company trip to Italy. That's Paul Tvete there on the right, and myself in the middle with the white T-shirt. Arnt Gulbrandsen should also have been in the picture, but he has been replaced here with my wife, actually, purely for aesthetic reasons. Anyway, we, in May then, 30 years ago, the first release, version 0.90 of this product, was put out in the public. And as we all know, it was called Qt. And we got a really cool 90s logo and everything. It provided a cross-platform widget set for Windows and Unix X11, and with native look and feel. And at this time, that meant Windows 95 and Motif. And we prided ourselves that we were doing pixel by pixel correctness of the emulated look and feel. And that was implemented using a cross-platform painting API called QPainter. And that API was integer based, because this was long before anti-aliasing and such fanciness. This was the good old time when pixels were real pixels and no display scaling and things. And it came with the Canon tutorial that has been playing here, showing how to implement a little game in only 14 simple steps, and but not least showing how to use the painting API to create custom graphics. And this was an immediate, although success. And we kept on developing it through the 90s, and towards the end of the 90s then, computers were evolving, and we felt, well, now we can finally leave the old world of the 16-bit processors behind, going all 32-bit. So we could change the base type of the QPaint engine from short to int, from 16 to 32 bits. And with that, releasing a major new version, Qt 2, and having an even fancier logo. The graphical user interfaces out there in the business is also evolving. Like Windows 2000 is coming out with new features and so on. And we are in Qt are keeping up. We are evolving Qt in step, and we're starting to see that Motif is not. There's not so much development going on any longer on the Motif side. They're not coming out so many new features. So we are starting to feel a little cocky in Qt. in the Qt 2.1 release note, we say, I have to quote this for you, that we have added support for drag and drop between Motif and Qt to make your Qt applications interoperable with those Motif applications that survived the year 2000 problem. Ha! Anyway, the major new feature of Qt was customizable widget look and feel, custom styling, which was easy enough to do possible since we were anyway controlling all the widget painting. So in the screenshot here, we see the same application running in Windows style, in CDE style, and in our own breathtakingly beautiful Norwegian wood style, which, believe it or not, actually landed us a license sale, since the customer said, well, if your product is flexible enough to do that, it can surely do what I need it for. So in the Q2 timeframe, though, we also saw the market for an embedded version of Qt, targeted at built-in little Linux computers with limited memory and power. So the X11 Windows system was too heavy to run on these computers. So you just had a blank operating system. And so what should we do with Qt then, that when we were depending on the native Windows system and Paint engine? And the solution then, again, in typical Qt style, was, well, we need to build our own. So we built QWS, the Qt window system, a basic Windows system that provided the basic functionality that was needed, and the Qt GFX Paint engine, which broke all the painting into basic little operations like draw line, fill rect, bit-blit this image data. And those basic operations were chosen so they were suitable to be hardware optimized by the 2D accelerated graphics cards of the era. They, of course, had no standardized API, so we provided custom drivers for the most popular brands. However, there was also a pure software CPU implementation, so you could run Qt embedded directly on the Linux frame buffer, only also a pure software painting. And so this was sort of a shades of things to come. As the new century rolled in, Qt was having ever more success, and we invested in a fancy new graphical profile and even more powerful logo. And you could even buy Qt on a CD-ROM and in a cardboard box. Finally, Qt was a proper product, as the standard was at the time. Apple, in these years, introduced a whole new rework of their OS, the version 10 called OS X, and since that was Unix-based, it was suddenly a much better fit for the Qt code base. So we added Qt Mac as the third desktop platform for Qt, and with that, the third major version of Qt, Qt 3. And the Mac port came with not one, but actually two native paint engines for Qt. One for the established stable Quick Draw API, and another for the new developing Core Graphics API with all the fancy stuff. Leaving the Middle Ages behind, then, we enter the Renaissance with brave new radical ideas. Since out in the industries, graphical user interfaces are becoming more advanced, more fancy features are released and being requested all the time up through the noughties. And we find that it's increasingly hard to deliver this with our architecture building on the native paint engines, particularly on the aging X11 Xlib platform. So we find ourselves in the cross-platform trap of being limited to the least common denominator of the underlying graphics engines. Solution, again, typical Qt style. We need to build our own paint engine, effectively then moving the cross-platform wrapping layer yet another level down in the graphics stack. So we started the Author project to develop this raster engine, having the architecture of doing all the painting, the rasterization on the CPU on application side, just into a Q image effectively, and then just bit whatever was changed in the last update down to the underlying Windows system. And this freedom then to add features to the paint engine was really appreciated by the developers. They went wild and added all sorts of new features like anti-aliasing, giving smooth contours over partially covered pixels. This again making it meaningful to introduce floating point coordinates to the painting API, QPointF, QRectF. They added painter paths, gradient fills, semi-transparency with alpha, even selectable blending modes. You know, we were practically Photoshop. at least it felt like it for a while there. And this new painting architecture then became the basis of the fourth major version of Qt. And it also enabled a powerful new graphical canvas widget, the QGraphics view, allowing developers to place their custom graphics on a huge scrollable and zoomable canvas. And it became the basis of countless customer projects. Qt 4 also introduced the OpenGL paint engine, an alternative backend to QPainter that allowed the rendering to happen on the GPU, actually. So while still using the QPainter API, you had GPU rendering. It showed great performance for some things, but less so for others because of all the state changes. It was a kind of impedance mismatch between the APIs there. These years, of course, was also the years of the smart devices and smartphones coming to market, and with them a whole new kind of graphical user interfaces with floating liquid design tuned for touch screens. So we added a new development paradigm to Qt, the Qt declarative, to make it easier to develop these kinds of user interfaces. With the declarative QML language and the GUI toolkit called Quick, which in this initial version was actually based on QGraphics view. So Quick actually had the whole widgets and QPainter graphic stack with it. And with all these new features, Qt became so cool that even Nokia decided to build their future smartphones with it, as you may have heard. But Nokia really pushed for the graphics to be GPU-based, to utilize their fancy hardware in their modern smart phones. So that became like the impetus for us to really enter modern times, like the industrial revolution of having, of seeing that there are powerful graphics processors everywhere, and we need to utilize this power. So we decided to go all in on OpenGL. since that was the standard API to do graphics programming at the time, to talk to the GPUs. And that became then the Qt 5 series, the very long-living Qt 5 series. Qt Quick was refactored, throwing out the widgets and QPainter graphics stack again, and instead based on a scene graph architecture for doing OpenGL rendering. Also, we provided the functionality for the customers to do their own custom shader programming directly there in QML. So very powerful possibility for graphics programming there. But of course, a bit low level. So if you wanted to draw higher level custom graphics, what could you do? Well, you had the Qt Quick painted item, which basically gave you a C++ callback, so you could do QPainter usage again. And you had the Qt Quick canvas item, giving you the HTML canvas API. Again, behind the scenes, ending up in a QPainter and CPU-based rendering. And both of these with imperative APIs then. So not until Qt 5.10 then came finally a module that gave you a declarative API and GPU-based rendering, namely the Qt Quick Shapes module. And with that, we are finally coming to our own times, because as this decade rolled in, it no longer looked like OpenGL would be the best choice for a cross-platform API. Apple was discontinuing it. Microsoft was focusing on Direct 3D, and this new Vulkan thing had appeared. And no really good cross-platform API for GPUs was available. So what to do? Yeah, well, what is the Qt answer? We need to build our own. So yet again, doing that in this form of the rendering hardware interface, RHI, building a wrapping layer for the different GPU APIs, both OpenGL, Vulkan, Metal, and Direct 3D. And Qt Quick was refactored yet again, moved over to build on RHI. And we see here the screenshot of the classic Qt 5 cinematic OpenGL demo, instead running on RHI. So this then became Qt 6 with a lot of new functionality that I'm not going to talk about, since we're only here focusing on the 2D graphics. And as for 2D graphics in Qt 6, the focus there has very much been on vector graphics. In version 6.6, we introduced the curve renderer, a new backend for Qt Quick Shapes, with more advanced pre-processing, more advanced shaders that yields anti-aliased rendering without super sampling, and allows deep zooming without retriangulation, as we see here in the prismatic angel demo. Then with Qt 6.8, the first release of Qt Quick Vector Image, similar to the Qt Quick Image item, but it shows vector graphics instead of pixmaps. It provides automatic translation of the vector graphic file formats into QML, particularly then to Qt Quick Shapes. And this translation can happen either at compile time or at runtime. And so far, support for SVG has been released. I see I'm running a bit out of time on this, but if you want this, you can have more information about this and more demos at the R&D desk right outside here. Anyway, I promised you a little teaser of things to come. And the first of that is what we're working on now, is adding support for animation to vector image. So showing animated vector graphics directly in Qt Quick, both SVGs, both with native animation and with CSS animation, and also looking into adding support for the Lottie animated vector graphics format. And this is showing great promise as a fast way to get designers' animations quickly into Qt Quick applications. Number 2 then is a high-performance light painting API, where the idea is to trade advanced graphics features, which you not often need, into high performance. And this is particularly then suited for rapidly changing throwaway graphics frames. For example, real-time curves from measurement equipment. It is based on RHI, so the power of the graphics processor is utilized, and it has an imperative API. And it shows very promising performance gains. And that's it. 30 years in 30 minutes. So I just want to say thank you so much to each and every one of you, users, contributors, customers, that has made this whole story possible. Back there in the 90s, I certainly never expected to be standing in a place like this. Again, thank you very much, and questions will be taken in the bar right after this.